Welcome to Engage Math, Lesson 2, Problem 2. So we are looking today at this process called cross multiplying, which is a really handy way to solve an equation when there's one fraction on the left and one fraction on the right. So when we have that situation, we can cross multiply. So let's start off with this first one so you can see the process. I'm going to kind of draw these little like butterfly wings for right now just to kind of show you what we're doing. So the 3 times the x gets multiplied together. So the one wing is this times this, the 3 and the x. They get multiplied together and give us 3x. Then the 6 times the 8 gives us 48. So we divide both sides by 3. And just like that, we get x equals 16 as our final answer. All right, let's go to the next one. Now this negative right here, I'm just going to make sure you know that's a division symbol. This negative right here in B, you could either put it with the x or with the 4. It doesn't matter. But just for the sake of deciding on one way or another, I'm going to put it with the x, so it will not get double counted. We won't count it with the 4 as well in the denominator. So negative x times negative 7 gives me a positive 7x. And now it's a positive 4 in the denominator, so it's 4 times 4 equals 16. Divide both sides by 7, and x is equal to 16 over 7. And we are done. All right, so let's go to the next one where we now have a 5x. So I'm going to do our wings again, and 5x times 3 gives us 15x, and then 9 times 5 gives us 45. Divide both sides by 15, and just like that, 15s cancel, and we quickly can solve these equations and get x equals 3 for this one. Okay, for the next problem, it's a little bit trickier because when we cross multiply, the 2 has to get distributed to the x minus 2. And then, of course, we have 7 times 4, or 28. But I just want to make sure you see this is going to become 2x minus 4 because that 2 distributes equals 28. So now we add 4 to both sides, and now we have 2x on the left equals 32 on the right. And then when we divide both sides by 2, we're going to get x equals 16. All right, that's it for that one. Okay, so for this next one, we're going to be distributing a lot, but I'm not going to show you the wings this time. I'm going to assume you recognize now that the negative 7 is going to distribute to that 6x minus 2, and I'm just going to write our new equation. So negative 7 times 6 is going to give us a negative 42x plus 14, because negative 2 times negative 7 is a positive 14, and then we have negative 5x minus 60. All right, at this point, I'm going to add 5x to both sides, okay, just to get the x's on the left side, which is just my preference, but you could do it either way. And then I'm going to subtract 14 from both sides, so the number, the 14, will go to the other side as a negative 14. So I'm going to change the color just so you can see this. The 14s cancel, the 5x's cancel. So negative 42x plus 5x gives us a negative 37x. That's on the left, and on the right, we have a negative 74. Now we divide both sides by negative 37, and we get x equals a positive 2. All right, so let's go to the last one, which is going to be a fraction when we get our final answer. So I'm going to distribute again, and I'm going to go back to the red, and we're going to say 4x minus 36 equals, and we're going to get a negative 12x plus 6. All right, I am going to add 36 to both sides because I want the number to go to the right. So how I get rid of it is by adding, since it was a negative 36 or a minus 36. And then I'm going to add 12x to both sides so that the 12x will go to the other side and match with the 4. All right, so now I'm going to change our color again so you can see what we have. So on the left, the 36's cancel. On the right, the 12x's cancel. So we now have 16x equals 6 plus 36, or 42. Divide both sides by 16, and we're going to get x equals, I'm going to just do it right over here. I know it's getting a little squished there. X equals 21 over 8. I just reduced 42 over 16 to 21 over 8, and we're done. Thanks for joining us here today at Engage Math.